The perpendicular and angle bisector theorems. The perpendicular bisector. Definition. The perpendicular bisector of a segment is a line, ray, or segment that is perpendicular to the segment at its midpoint. So given that MP is the perpendicular bisector of AMB, the definition allows us to conclude that AM is congruent to MB. So this portion here is congruent to this portion here, and MP is perpendicular to AMB. So this angle here is a right angle. The perpendicular bisector and its theorems. If MP is the perpendicular bisector of AMB, then AM equals MB, so this length equals this length. AP equals PB. AM is congruent to MB, and AP is congruent to PB. If M is the midpoint of AB, P is not on AB, and AP is congruent to PB, then MP is the perpendicular bisector of AMB. Alright, here we have a two-column proof, and we start with our given information, which is that MP is the perpendicular bisector of AMB. Therefore, MP is perpendicular to AMB, and AM, this length here, equals MB, this length here, because that is the definition of a perpendicular bisector. Angle AMP, so this angle here, is congruent to angle BMP, this angle here, because perpendicular lines form congruent adjacent angles. PM is congruent to PM, this shared side right here between these two triangles, and that is due to the reflexive property of congruence. Since we previously saw that AM equals MB, we know that segment AM is congruent to segment MB because that's the definition of congruent segments. Since we have now shown that AM is congruent to MB, PM is congruent to PM, and this angle here is congruent to this angle here, we see that by side, angle, side, these two triangles are congruent. Since these two triangles are now shown as congruent, we can now conclude that AP here is congruent to BP because corresponding parts of congruent triangles are congruent. And finally, since these segments are congruent, their measures are also equal because that's the definition of congruent segments. And here is the full proof. In summary, if MP is the perpendicular bisector of AMB, then AM equals MB, AP equals PB, AM is congruent to MB, and AP is congruent to PB. If M is the midpoint of AB, and P is not on AB, and AP is congruent to PB, then MP is the perpendicular bisector of AMB.